Okay, YouTube, in this video, what we're going to do is emphasize the period of a tangent function. So in our last video, what we indicated was that the period of sine and cosine is 2 pi. That is to say that because of any angle t, terminating at this point xy, if we were to add on 2 pi to that, we would just be back around the unit circle at the same point xy. And so we would have the same cosine and the same sine value as what we started with at t. That is, if we add on or subtract off multiples of 2 pi. Well, when it comes to the tangent function, the interesting thing is, let's recall that our tangent function of an angle t is equal to, if we know the sine and cosine value of this point y, x, or xy on the outside side, then we would say that the tangent of this would be y over x in this particular instance. And so that being said, we can see here in this diagram, in particular, that at some angle t here, which has an arc associated with it of t, we can see that there's this point P, and the point P is this point xy. So if we were to take y divided by x here, we would get some tangent value, and we say that this is the tangent value of the angle that terminates at that point P. Now if we were to add on 180 degrees, or pi radians, add on pi radians to our t, so this is t plus pi, what you're going to see is that you're diametrically opposed to this original point P at this point Q. And this point Q, of course, it would have to be negative x and negative y if this was positive x and positive y, and we just rotated at 180 degrees. So that being said, what we're seeing here is essentially that if we were to take the negative y divided by negative x, which is what you see up here, you still get the same thing. So unlike the sine and cosine functions, tangent is unique, and of course, so is its reciprocal function, cotangent, but it is unique in that it is periodic, but periodic not with a period of 2 pi, but with a period of pi. So the important thing to take away from this is that the tangent and cotangent functions are periodic functions and have a period of pi, not 2 pi. So in general, let's go ahead and kind of wrap up what we know about the period of these trig functions, but essentially that they will repeat themselves over and over again as we rotate around the unit circle, or as our angles get bigger and bigger. So it is true to say that with respect to sine, cosine, and tangent functions respectively, we can see that for any integer n, integer just means a whole number, and a real number t, which is just an angle, what we're going to see is that at least sine and cosine here, the sine of an angle plus any multiple of the period, or the cosine of an angle plus any multiple of its period, then what we're going to see is that that's the same thing as what you started with originally. And the same thing's true with tangent. It's just that you notice that with tangent we say tangent of any angle plus multiples of its period. We see that the tangent, we say period of only pi, and then we say sine and cosine. Oh, you guys, that's really bad. Cosine. We have periods of 2 pi. Cheers.